As a second example of computing inverses for restrictions of non-bijective functions, let's consider the squared function. The squared function, so f of 2, will map real numbers into real numbers which are positive or 0. So this is the codomain and range, and every x is assigned to f of 2 of x, which is by definition x squared. Graphically, this function is just a parabola. Let me draw it. The following parabola, like this. So on the horizontal axis is the domain R, so this is where x lives. On the vertical axis, well, it's all the positives, so it starts at 0 up to plus infinity. So, and on the vertical axis lives the numbers x squared. Now, you can immediately see that is not bijective, because every single number that you choose here, for example 1, well, 1 will be mapped into 1 squared, which is 1, well, and minus 1 is going to be mapped into minus 1 squared, which is again 1. So we have two elements in the domain mapped into the same element in the range, and thus this is not 1 to 1. Note, however, that it is onto, because I chose the codomain as the range for this function. So the key issue now is if you want the inverse for this thing, the key issue is to solve the fact that it's not 1 to 1. And you do that by using restrictions. Well, let's construct, for example, two easy ones. So f of 2 greater or equal is one possible restriction. Let's define this function to be whose domain is all positives and 0, and maps into all positives and 0, and every x is going to be mapped into f of 2 greater or equal of x, which is, by definition, x squared. This function here corresponds to this, graphically corresponds to this point plus all these points, so all this positive curve here. So this is f of 2 greater or equal. This is the function here, the first restriction. The second one, I think it's obvious, because it's f of 2 less the lesser function assigns the negative numbers, so from here to here, into positive reals including 0, and every x again is going to be mapped into the number f of 2 less or equal of x, and which again agrees with the original function x squared. So again, let me just put it like this. This part and all these points here. So this is f of 2 less. The fact that the 0 is included here on the right f is just a matter of convention. I could also have put it here. So these two functions are bijective, okay? Everything is fine, and so they have inverses, while this one do not. So let's define those. So f minus 1, let me write it like this. It's probably easier to think like this. So we want the inverse for this. So is f of 2 greater or equal? I want the inverse of this, and then I write minus 1. It's usually easier to think in that way. So that function here, then minus 1 on top, just to say that it's the inverse of this. And what does it do? Well, it's going to assign these numbers into these numbers. So it's positive, all the reals, positive reals into positive reals. And the elements here, let me call them y, so it's the input of this function, is going to be assigned to the function f of 2 greater or equal minus 1 evaluated at y, and by definition, well, we already seen this, by definition, this is the solution. The solution of the solution x greater or equal to 0, so it's positive, you want positive solutions here, of some equation which is x squared is equal to y. Y is the input here. So this is by definition. Now, let's define the second one. You have f of 2 less minus 1. It's going to assign now these numbers into the negative ones. Okay? And again, every y is going to be assigned to f of 2 less minus 1 evaluated at y. And that number corresponds to the solution x, but now negative, because it must belong here, of what? Well, of the equation x squared is equal to y. So essentially, we are restricting the equation. See, when we have equation, you can seek the solution for it. Well, but we have to say where we want to seek the solution. Well, we want to seek for those x's which are positive. In this case, you search for those x's which are negative and satisfy that equation. And you see? Now, let us just think a little bit. Is everything okay here? I hope you can see there is a problem here in what I wrote. Can you see it? I smuggled an error here. Can you see? Is this bijective? Graphically, is it bijective? It is. You can see it graphically because it maps 0, 1, 2, 3, all the numbers, all the real numbers into reals. So you have this line. But here, there is a problem here, right? Because can you see? Can you see the problem here? Because what is the range of this function, right? Because if you have all the reals, all the negative reals, but that does not include the 0, but the codomain has the 0 here, right? So you see, there is an element of the codomain, namely 0, which is not assigned to any x in the domain. So you must remove this thing, just like we did in previous video when we removed the 2 from the codomain. You just remove the 0, and now, of course, every real number here, which starts from 0, excluding the 0, up to positive infinity, all those numbers here now have a corresponding x, but 0 do not. Okay, because you are assuming this thing here. Can you see? And of course, you have to exclude this thing here. Okay? You can actually see this in another way. If 0 is included here, well then f2 lesser minus 1 of 0, we have to solve for x less than 0 of the equation x squared is equal to 0. But the solution of that equation is x equal to 0, but x equal to 0 is incompatible with x less than 0. So you have to remove that thing. Can you see? Now, this is just one example of the inverses that we can construct for this squared function. There are other restrictions that you can do. Okay? There are other restrictions. For example, let me just illustrate at least one example for you to see. You see, because the restrictions that we chose, it just split the thing in half, but there are many others. So let us see that. At least one more example for you to see what happens. Just me go show you these details. Let's do it graphically first. We could, for example, choose the following restrictions. For example, to include, for example, all the numbers from 0 up to 1 open. So this is a restriction of our function. So f of 2, now restricted to the interval 0 and 1 open, will map all the numbers from 0 to 1 open into positive reals are 0, and every x is mapped into f of 2 from 0 to 1 of x here. And that number, of course, agrees with the original function, as you can see from the graphic. The green and the blue one are superimposed. So this thing must be defined x as x squared, the same number that the f of 2 of x will take in this interval. So far, so good. So what's the inverse now? Can you see? Can you write it right now, the inverse? Let me write it. Is again, this thing inverse will assign our reals including 0 to all the numbers 0 and 1, and every y will be assigned to, well, f of 2 from 0 and 1 minus 1 of y, which by definition is a solution. Solution of what? Of all x's belonging to 0 and 1 here, of the solution of what? Of the equation x squared is equal to y. Can you see? Again, you follow the idea, you just create a restriction, you want it to be bijective, and then you just compute the inverse by definition, that using the definition that we saw previously. Now, again, is everything okay with what I just done? Is everything okay? Let's see. First question is this thing bijective? Well, it's f of 2 restricted between 0 and 1, but what is what is the codomain of this thing? Well, in the range. Well, the range of such a function, well, is all the images of all x's in this interval. But that corresponds to those y's between 0 and 1, not all positive reals. So this is a problem. The function is not onto. It's 1 to 1, but it's not onto. So the issue is here. This must be, let me put it in red for you to remember. What you see here must be all the images between 0 and 1, excluding the 1, because those are the images, the range of the values between 0 and 1. This is very important here. Very important, this idea. And now I have to fix here. Again, from 0 and 1. Again, can you see how important this is? Okay, you have to make sure that the function is defined properly before you actually compute this thing. Now, like this restriction, you can make many others. You just have the trouble and the work to specify what is the range for each one, so that you make them one-to-one. Note, however, that restrictions like this, you could make the following restriction between this point and this point. For example, minus 1f and 1f. Restrict this thing between this interval, but notice that it is not one-to-one. That restriction did not solve the fact that the function is not one-to-one. Because again, if you restrict the restriction that you are about to construct, have this point assigned to this image and this point assigned to the same image, and the fact that it's not one-to-one remains still for the restriction that you are about to construct. So you have to choose them carefully. As long as you do it, anything works. You just write it like this, and you just invert using the definition. Now, let's move on to other issues.